Hello, hello, hello. I am Learning Tech, and I'm here to tell you about the mega lab that I'm building and the architectural mindset and the reason why I have designed this network as I did. Now, this lab focuses on segmentation, redundancy, wireless, voice, security, enterprise access, firewall protection, routing, and high availability. Now it looks all crunched up together, so I apologize for that. The idea that I have for this network is a bank. And banks care about uptime, security, redundancy, and segmentation. Now, the first thing that you notice on this design is there's no core layer. I only have distribution switches and access switches. Right here, 4 access switches and 2 distribution switches. This is called a collapse core. Instead of me having all 3 of the access, distribution, and core, I just combined it distribution and core together. Because this is more like a mid-size going to a large network. And it reduces cost, complexity, and management overhead. And I really like this design because it still gives high performance, scalability, and redundancy. Now, I didn't configure anything on this network yet. When I start configuring, I will probably do distribution first. And the reason why I'll do these distribution switches first is because that is the brain of the network. This is where the routing happens. This is where VLAN gateways come alive. This is when redundancy exists. Traffic design fully happens. I will also use the star design, as you see here. I have like the access switch going to distribution 1 and access switch going to distribution 2. It's like a star. I have a star here too to the firewalls. And that keeps redundancy. So if one link goes down, you have another link up while you're troubleshooting and trying to figure out why the other link went down. I will also implement high availability, and I would use HSRP. Now, HSRP is a protocol that has redundancy for gateways. If you only have one gateway and that gateway goes down so you can get to the internet, if that gateway goes down, you won't be able to communicate. Your whole network goes down. With VLANs and segmentation, VLANs are in their own network. So they need a gateway so they can communicate through VLANs if you want them to communicate. It's very important to have gateways so they can actually get out and explore outside of their network. The next thing that I will do, the routing protocol that I will actually choose, I'll actually choose OSPF. Static routing, I would not do. That is just too much upkeep. What makes OSPF so great, it learns routes automatically. It reroutes traffic when it detects a failure. And it can scale very well. OSPF is mostly used in enterprises. So I would like to do that because if anyone else would touch this network, they most likely would know OSPF because it's so widely known. The next thing I would do is VLANs. There's going to be so many VLANs. I will have VLANs for my users over here, the tellers. Also my executives, for the loan office, for the IT admin, for cameras, the wireless, and ATM systems. Like my guest Wi-Fi and also my server will have its own VLAN. The reason why I'm doing that is for security purposes, performance, broadcast control, and it makes it a lot easier to troubleshoot. We have everything segmented. A guest Wi-Fi should never be able to communicate or be on the same network as ATMs or the executive office. That should not be a thing. So I'll do those next. The next thing I'll do is the access switches. I'll do the access switches, and this includes the PCs down here, the phones, and also the wireless, and then the cameras and the ATMs. I'll do the access switches. And access switches, the access layer is where users physically connect into the enterprise. So I'll make sure the brain is up, the brain is working, and then I'll start connecting everything else. Now the reason why I use multiple access switches is I want to separate the access layer by operational purposes. Like for example, switch 1 and switch 2 are handling, regular users. And switch 3 and 4 are in a whole different ball game. They're handling executives and IT admins and cameras and ATMs and wireless. It's much cleaner and better for overall control and operational purposes. Why I separated the executives from the other users is higher security, more restricted access, and additional monitoring. Now, I also separated the IT admin as well from the other tellers because I want them to be able to have their own bandwidth and have their own network when they're troubleshooting, when they're monitoring, when they're watching, when they're using SNMP to look over the network. Now, camera traffic, as I learned, can use up a lot of bandwidth. So I thought to myself, it would actually be more beneficial if it was also segmented and not mixed in with phones and printers and all this other stuff. The amount of bandwidth that it uses could slow down your network. And I don't want to slow down the network, especially for cameras. Cameras are really good for security. And if your camera goes down, if it's already separated, it's easier to troubleshoot. Now, I separated ATMs because this is critical, especially for a bank. ATMs are highly monitored, filtered with ACLs, and protected with firewalls. This reduces risk when they're in their own VLAN, when they're separate from everything when they're in their own little island. This reduces risk. Now, when I configure, I will configure voice VLANs, because phones shouldn't share the same traffic space with PCs. Phones are very important, especially for a bank setting with the tellers, the executives. I want voice traffic to sound cleaner, have first priority, and easier to manage. That's what I'll do next. The next thing I'll move on to is the wireless. I'll move on to the wireless and the lightweight access points. I will start configuring that. Instead of configuring every AP, I will just do the wireless LAN controller, centralized manager, and it will configure these for me. So I'll configure the SSIDs, the security, the roaming, the wireless policies, and I will do it on here. And this is the brain for the lightweight access points. It's better to just have one controller that communicates to the other devices. It's quicker, less configuration issues that you may do. And it keeps operations smooth. Now the next thing I will do will be probably I'll do the firewalls. The next thing I'll do is the firewalls. Now, firewalls are very important because they expect packets. They make sure no malware gets through. They watch the traffic and they gateway your traffic. Firewalls can perform NAT, traffic filtering, and security enforcement. That's why I placed them right here. So when it's going to the ISP router, anything that's coming in, it will go straight to the firewall. And I have two for redundancy. Same thing here. Anything goes to the distribution switch, going straight to the firewall. I want every packet to be watched and monitored because people will constantly try to send malware, especially through a bank enterprise. Then the next thing I would do is a ISP router, and that's what I'll configure next. This is the internet connectivity, the upstream routing. This is my WAN edge connectivity. I want it to be able to reach external networks and reach the internet. So that would be closer to my last thing of configuring. And especially what I'll do is Ether channel. I will configure Ether channel, especially doing this enterprise network. Ether channel is one of my favorite things actually, because you can load balance with Ether channel. So you have spanning tree. I have a video on spanning tree if you want to hear more about it. But spanning tree will block a link. So you have a wasted link not used. And it's actually right here. You can see it. So that's a block link. I'm going to configure Ether channel and do load balancing on it so I use all of my links while also not creating a layer 2 loop, a broadcast storm. Ether channels create redundancy, higher bandwidth, and failover protection. And spanning tree will see Ether channel as one physical link. Not two, not four, but one physical link. That is absolutely awesome. And the reason why spanning tree will matter a lot, especially in this topology, because with my star topology, if spanning tree did not exist, I will have loops everywhere. Loop, loop, loop. All these will be loops. And that will cause a broadcast storm, and that will shut down my network completely. This network will go down so fast because I have so many redundancy links connected together. And layer 2 frames don't stop. They don't have a time to live. They just keep going forever and ever and ever. That's why spanning tree protocol will have a block link, so it looks like that link is actually down, and that's where the traffic dies. That's why that link is not used, because it looks like it's shut down, like it's cut off. So spanning tree will definitely be very important to me. I will also make sure I'm configuring spanning tree with load balancing, and also making sure through the VLANs I'm not creating a loop either. And I will not configure DHCP on the ISP router. I just wouldn't do that. I'll do it on the server over here. I'll have a server to itself, segmented from everywhere else, and I would just have the server do DHCP. That's its job. DHCP, DNS, stuff like that. My ISP router will already be doing a lot of work. My distributions will already be doing a lot of work. I don't want it to use any more CPU than it has to, or the firewalls. So I'll let the server do all the IP addressing, giving out the proper gateways for the PCs, the DNS assignments, endpoints, making sure they can communicate to different endpoints. This also reduces a lot of risk too, of when you separate everything and give everything their own separate jobs. It's really good for the network, because if you have a DNS problem, you know to go straight to the server, or a DHCP problem, you can go straight to the server. Now, this design matters, and why I like networks built this way, this shows you how traffic flows. And me looking at it, it looks like traffic will flow very, very well. This also shows how security boundaries are created, and this shows how businesses can stay up with little to no failure. So yeah, if I do a quick run through, I would I would configure distribution switches first, VLANs, trunks, Ether channel, and then I'll do HSRP for high availability, OSPF access switches, voice VLANs, the firewalls, DHCP servers, wireless controllers, access points, endpoints, and then I'll verify everything with testing, making sure the pings work, making sure everything's up. That order matters because enterprise infrastructure must be built from the inside out. I always think about like it's a body. I always think about start with the brain and then start with the nervous system. Start with the heartbeat and that will make sure that your blood is flowing, and make sure your blood is flowing to the heart. So the heart is beating. Every protocol that I will implement will solve a business problem. Every design choice has a purpose. And my goal is not to memorize commands. The goal is to understand how enterprise systems work together, like a bigger picture. Thanks for listening.